Hi everyone, welcome back to Making a Pokemon Save Editor in C. So I have literally just turned on my computer and I've sat down to jump straight back in, so I might be a little bit slow, but hopefully it won't be too much of a problem. So in the previous part, we started to look at making a new Pokemon from scratch, and I kind of got stuck on part of making a new Pokemon, which is giving them random values for their personality value and the OTID, for example. So, yeah. What I found was that the same random number would be generated each time. It didn't matter if I recompiled or anything like that. I believe that you can probably spot the problem straight away. I did some reading after the previous episode, and it was something that I resolved very, very quickly. Basically, when we do random number generators in general, you have essentially a random device, something that produces random numbers, and it always needs to be initialized with some kind of state or seed for producing those random values. To make it random, like a non-reproducible random, you don't care that each time you're grabbing random numbers, it's different. If you don't care about that, you want to use your seed as a quote-unquote random value, or you want that value to change each time you run the program. So very commonly, random devices are initialized with the current time, like the Unix epoch time, like that one big long number every computer has that says basically number of seconds since 1970. Yeah, January 1st, 1970. So that is clearly what we want to do. I've probably lost the tab, but probably if I was to just search C random number generator, let's see what we get. So there's how to generate a random int, and you can see that we have a yes. So this sums it up pretty much perfectly. We grab time, and we initialize some kind of random device with a value. Now, I don't know if that's actually at odds with what was said in here. I guess not. So we do S. So you can do srand, which doesn't seem to be in here, even though it's in standard lib. Okay, so there's another one here. These interfaces are obsoleted by arc4 random 3. So let's actually look back at random, which is probably what we want. So srandom, like srand, as we can see, it sets the initial seed value for future calls to random. This will by default produce a, yeah, and so on. So I'm guessing if we call so we call srandom to begin with, and then we can just call random from that point on. So the personality value can be srandom, and we use time to do that. Although actually, no, sorry, srandom is a void. So what we want to do here is call srandom with some kind of value, and then we can just use random each time after that. So we also want to include time, because that's how we want to grab the time value. And it looks like that was the syntax. So we actually want man 3 time. Yeah, so get the time of day. Yeah, the value of time in seconds since 0 hours, 0 minutes, 0 seconds, January 1st, 1970 UTC. So, yeah. Cool. Okay. That looks fine. So this should now then produce actually random values. And I did have some kind of test for that, which might be in my scratches, maybe. What's in main.c? Yeah, okay. So if we were to just test this out real quick, so let's include time.h. Don't do any of that. And then we'll do srandom time null. Now, if we were to gcc main.c, then we get 2 random values and they change each time, assuming that you wait more than a second between each time you run the program. But there we go. That is fine. So this is what's going to allow us to set random personality values, OTIDs, what have you. So that is that problem taken care of. And we can focus now on the actual data. So this was the other kind of meaty bit that I didn't really get into last time, just because of time. So we are once again looking at the Pokemon data substructures. I don't know the best way of actually generating this data, and this is where things get a little bit more complicated because you know, we have a 32-bit value here for experience, and this derives the Pokemon's level based on its, how quickly that Pokemon actually levels up. So this graph here is plotting how much experience you require per level for each kind of category of Pokemon here. So you see that if we have a fast growing Pokemon by level 100, we need significantly less experience than one called Fluctuating, which seems to have a bit more of a curvy or a wavy line. I'm not sure if you can see it very well on the screen. But yeah, there's essentially a max number of kind of XP that Pokemon requires based on its species. So this is a little bit of a pain, or this will be a bit of a pain to work around. Okay, this actually says how much XP you need for the next level. So Fluctuating is like, whoa. And then the erratic one kind of dies off. So let's see then. Okay, so there's actually quite a bit of mathematics here. Yeah, okay. So this says, here are your levels, and here's how much total experience you would actually have. And that is derived from these equations. So I'm not sure about how we would go about supporting this. It's not so much the maths that worries me, but we need to be aware that every Pokemon has a some kind of growth rate, which we don't necessarily know. Is it actually in here? Is it in the text file at all? It is not. So Yeah, that's a bit of a pain. I guess what we could start by doing is maybe adding in these values for the Pokemon, because I don't think we have that yet, do we? So if I did Bulbasaur or Squirtle, it's not there. So let's try and start with that. So let's make a new header. In fact, let's actually do with a C file as well and contains a header. So this I'll call CSAV Dex for Pokedex. And then we can do enum. Let's call this Pokedex. Why not? And we're going to have to do some scripting again to make this into a nice format. So can I reuse anything here that I did before? Because I'm pretty sure we have... Okay, great. I have move to enum, move enum, and new move enum. Although move to enum looks like it's the largest, so let's see what's in this file. This is a correction of something else, so it may actually be move enum that we want to look at. Yes, we do. Yeah. So that's actually fine. We can probably reuse most of this. So let's say our text is the thing we copied a minute ago here. And then in this window we can paste. I'm not sure, is it saying these are line breaks? I hope so. Okay, so then the actual program will split by line. Oh, I just realized this is no longer move enum. It would be Pokemon enum, but sure. Let's just replace move with mon. Probably should have done that globally, but okay. So move becomes mon. And let's see for the moment what this actually does. Okay. This actually doesn't look too bad, although everything near the beginning seems to have an underscore. I guess because there's some... Yeah, there's like hidden white space on a lot of these lines. That's a little bit annoying. Not hidden... Well, maybe it's hidden white space, but there's some kind of... Sure, there was some kind of phantom, yeah, character on the end of each line, which is being translated into an underscore. So I think what we probably need to do is strip the right-hand side of white space. Probably before we replace spaces with underscores. And also what would be kind of nice is to have the regular number first, and then inside brackets we can do the hexadecimal. So it would again be int num with x. And this needs to be closed. And I don't know why it moved over so much. But let's see what this gives us. Okay, yeah, that's much nicer. what we also want is Mon to be it needs some kind of Mon needs some kind of prefix. Which maybe we can just have PKMN for now, and that works. Would probably help if I also did that. Yeah, that looks very nice. Did I quit Vim? No. Oh no, I did. Just had 2 suspended processes. Okay. Cool. Okay, so this we can just take to our clipboard and pop back into here. Not that. That. And let's indent those lines. And yeah, far-fetched. I'll get rid of the apostrophe. We have a few issues. So some more characters that simply... Why doesn't it like Porygon? Oh, because there's a Porygon 2. This is Porygon 2. So we'll just fix that. Yeah, Porygon. And that is our Pokedex. So we are without issue there now. So this is our Dex. We also probably need another enum for Pokemon growth rate, I guess we can call it. And we have all of these now. Are they all used in Gen 3? It looks like they are, apart from slightly fast and slightly slow. So caps lock, growth rate, medium, fast. Growth rate, erratic. Growth rate, fluctuating. Growth rate, medium, slow. Growth rate, fast. Growth rate, slow. And then there's unused, medium, fast, which I guess we won't worry about then. Okay, so those are our growth rates. So we probably need to have a function in maybe the Dex, which lets us calculate a Pokemon's level, or how much XP it needs, given a certain level that we're asking for. I didn't realize I was so washed out, by the way. And the music stopped. What's happening? Let's see. There we go. I didn't mean to pause the music, but maybe I accidentally hit it if I skipped a track. I also don't know why I'm so washed out. I've got blinds behind me, so... Is that gonna behave? I guess not. Okay, I'm just gonna have to be overexposed the entire time. That's great. Right, so... Man, this... The only thing that I'm afraid of here is how tricky this is gonna be to debug. for sure. Okay, so if we have... let's start with someone simple that we want to log in. Let's give ourselves another starter. So let's go for Bulbasaur. And I know that all the starters, I believe, are medium slow. So we have a Bulbasaur here. We can see, yeah, leveling rate is medium slow. Maybe I should rename that to leveling rate. So in this file, pkmn Pokemon leveling rate. So over here in the Dex, we probably want to have some kind of a function that will give us a uint 32T, which we don't currently have. Don't do that folding. Come on, Sea-Lion. Int types. So we get a 32T back. Let's call this calculate exp. So we probably want some kind of unsigned level and some... It needs to be a Pokemon species, doesn't it? So this is in our Dex, enum, Pokedex, yeah, let's just do species. In fact, let's do species first. And, I mean, level can probably be a short, right? Yeah? Okay. So, we probably want to have some kind of... There probably needs to be some kind of mapping of species to its actual leveling rate, and I'm not sure if that information is easily available. There's probably a list online somewhere, but I think it would probably be a bit too boring to try and track that down, so I'll try and do that off screen. So in the meantime, we can probably just call this, knowing that we have knowing that Bulbasaur is medium slow. So enum leveling. Oh, actually, no, it's not. It's not really an enum, is it? It would be. Let's just say like medium slow is. I mean, actually, we already know. It doesn't need to be. Doesn't need any indirection there. For now, we're just using medium slow. Cool. So if we go back to this page, we want to look at medium slow. So this is... okay, maybe we do need some kind of indirection. Oh, was I just call it? Okay, everything here was called growth rate. So let's actually change the word growth to leveling. Leveling rate medium slow. So let's pretend that we were going to have like a switch case here, and this does all of the calculations. So if we did case leveling rate medium slow, then we do a whole bunch of things here. Otherwise, our default would be to do something else, like set a 0. But let's just worry about getting this in for the moment. So what is my... Switch has 2 consecutive identical branches. Yes, I know. So can we return straight up? I think we can. So let's have our EXP. So in this case, EXP is 6 divided by 5 multiplied by level to the power of 3. Hopefully this syntax is okay. This probably needs to come from math. I would not be surprised. So here, I don't think we do 2 asterisks. I think it's POW. Level 3. And this is going to need to be casted back to a uint32t. Probably better, actually, is to floor this number. Yeah. What is your issue here? Use of integer division used in a floating point context. I'm sure that's fine. Okay, so this is after the power. So then we want to subtract 15 multiplied by pow level 2. Actually, let me look up pow, because what goes first? Compute x raised to the power y. Perfect. So that's that. Plus 100 multiplied by level minus 140. And that should be fine. Although I think I have too many brackets there. That needs to be closed out. That closes that one. Yeah, this looks okay. It might actually be worth looking at what floor does. That gives us a double. So, well, largest integral value not greater than x. I mean, it could be... Maybe ceiling is better. I don't know. And, I mean, we want to go through all of the switch, then return EXP. And let's assume that is okay. So interestingly here, let's see. Trying to think the best way of testing this. So let's go to main, and we pretty much don't need to do anything. We want to include let's say csab dex. So then let's say we have a new variable which we'll just call required XP, and we need to stick this in our header. So we want CSAV dex. And we need int types in here. And that should be fine. It may actually say int types here is redundant now. No. Okay. We'll do that as well, just in case. So Pokemon Dex, calculate EXP. Our species is going to be, what was it, Bulbasaur? And our level, let's say 10. So for a level 10 Bulbasaur, we need these characters. So let's see how this goes. It says 360. So we do have that table we spotted. Are we correct? For medium slow, we are not. I'm assuming this calculation doesn't change in generations. This is talking about what you get from battles. Okay, so annoyingly, I must have an issue there. Where's our equations? So 6 divided by 5 multiplied by our level to the power of 3. And that's block 1. Subtract 15 multiplied by our level squared. Add 100 multiplied by our level and subtract 140. So I don't see the issue there. But that does not agree with our table. Which is further down on the page. Yeah, so this is the total experience that's required. But I clearly have that wrong. Because it should be 560. I mean, we're not far off. But this should not be 360. Why are we 200? It's a bit suspicious as well that we're exactly 200 away. That is strange. Let's maybe see, can this be copy and pasted? Okay, it can. Let's try something like Wolfram Alpha. Oh, that didn't work at all. Somewhere, probably in the boxes you can see up there, I actually do have a calculator that can write equations into pretty much in this syntax, so that would have been really useful. But in the meantime, I suppose we'll need to just try something like this and see. So 6.5 multiplied by 6.5 multiplied by 10 to the power 3 minus 15 multiplied by... Oh, hang on, am I fucking with the... how this stuff is computed because of my brackets? I think that may be an issue. I might have been too keen with these. So we actually only need one set, I think, of brackets around here, and then one for the power. Yeah. So those minus 15 power level 2 plus 100 level, subtract 140. Maybe that will change things? No, it won't. Okay. Fine. Let's see then what our friend says over here. Minus 15 times 10 squared plus 100 times 10 squared minus 140 gives us a crazy number. Does it actually... Do we want double asterisks here? Now that's saying 9560, which is very wrong. 6 over 5 times 10 to the third, or 10 to the 3, minus 15. I wonder if this would be easier... with the n substitution. So 6, 5, n. Uh, 6 over 5 n cubed minus 15 n squared plus 100 n minus 140. Yeah, so I mean, that graph looks about okay here. Can we just say where n equals 10? 5, 6, okay, yeah. So my implementation in C is wrong. And I don't think I can express it though in C the same way that I did over there. Because I don't think I can just simply do... Yeah, like you can't do 6 over 5 POW level 3. So that is a bit of a pain. Minus 15 multiplied by POW level 2 plus 100 multiplied by level minus 140. Yeah. Although actually, I don't know if C-Line is trying to help me here by saying that all of these are redundant. I mean, what is that gonna do? Give us the same result. So where is my problem? Maybe the good old AI can help us. So let's plug this into this guy and say, how can I express this equation in C code? Oh, maybe these need Maybe these need brackets of their own. Multiplied by pow, and 3 minus 15 multiplied by pow, well, 2 plus 100 multiplied by that minus 1. Yeah, okay. And then let's do the recommended thing, which is adding a 0.0 to all of these. Was the AI correct? It was! Hooray! Okay. Nice. So this should give us whatever level we ask for. Let's then do... Let's go back to main. Let's do level 100 instead, which should be a much larger number. Yep. 1059860. Medium slow is here. 1059860. Perfect. Okay. All right. So that's for medium slow. I probably, is it worth filling out all of these just for the exercise of hacking in one Pokemon, which will be a very straightforward one. I don't think this is needed particularly. So that's species almost done, half baked. So let's also do all equations for EXP. Held item. We can probably do something like that. Didn't I add... Did I add items somewhere? I did not. So there's probably... Yeah. There's items here. Okay, this is expressed a little bit differently. This is all hex, so this would be a bit more of a pain to hack in. And not all of these items can be held, so the ones in the curly braces can't be held. All of this stuff, it looks like it's from Pokemon Colosseum. So these guys, so the TMs can be held, I think. But no, you've then got stuff, I saw Acrobike, you can't hold that. Damn, okay. So we need a way of seeing what are key items and what are regular items. I mean, I think they're all regular items, or items that can be held up to a certain point. So let's go all the way down to where we know there are key items, which I think is around here. And then the TMs can definitely be held, so we can also add those in, but we're going to need to be specific with the values here. Yeah. Yeah. So this probably needs some other kind of script here. So let's do vim item enum.py. So similar to what we've done before. Let's plug in our items here, and this time we're going to need to pass it a little bit differently. So let's say, so text is still split by new line. we then want to four-line in text. We want to say that the number and the item is line split by the equals once again. So for num, we want to remove that dash hex suffix. I don't know why it's playing like organ music, but sure. We then want to... I wonder if we can read these values in as they are. Yes. So... I actually don't know how we deal with hex numbers like that, as if it's coming in as a string, I'm not sure if we can just do... Yeah, no, we can't. Although, is there like a constructor for int where we can tell it's base 16? Lovely. So then num is int num in base 16. And then that's our number done. So for the item, we want to convert to uppercase probably. And replace any white space with underscores. What we should do, however, is set these values. So this is gonna be an enum that is every value is actually set explicitly. So we probably want to print something like we should also probably do a item prefix as well. So item, just noticed that typo there. Item equals num expressed in hex. And ending with a comma. And I don't know why it did that indentation. But sure. So that doesn't look too bad. I think we want some padding as well. We want to find the max length of the item, or we can just guess. We can just guess. What was it? R just or L just? I think it was L just. I don't know how long these can actually go for. 16, I want to say. Sounds like a sensible number. Not quite 16. 24? I mean, that looks nice in general. I actually think it may be 20. Yeah. Okay, that looks a little bit more sensible. Cool. What we then want to do is add the TMs here. So we don't want any HMs. We don't want things like Helix, Fossil. Those are all key items. These are Pokemon Colosseum items, so we can't use those. I have no idea what a battle CD even is. So we just want to grab these items here, and we'll add those to our text printout here. So paste should then work. Now here we are definitely going to want to remove instances of brackets as well. So let's replace any left bracket with nothing, and likewise for the right bracket as well. And we now need some more padding, so let's change this to 30. Yep. That looks pretty good. Pretty good. So there is a gap between items that kind of increment normally. So there's like well, no, there's over 255 regular items. But then we go down, and then there's a big jump as we go from here to there, from Yellow Scarf to TM Focus Punch. So it's probably worth putting in a comment for those as well, but we can do that actually back in the C code. And this is where we're probably going to need another source and header file just to keep stuff organized. This one may just need to be a header for now. I can't really think of anything specific about items, so let's call this CSAV items. Yeah. So let's call this let's call this items for now. Can always rename it later. So let's do the same indentation. We have some errors. So apostrophes, these probably are. And then up dash grade, I'll just replace with an underscore. Yeah, this looks pretty good. So here, so that is the break in our normal items as we move into TMs. And I believe those are the items that can actually be held. So that is good. Okay, what's next? We have PP bonuses. Now, that is interesting. This is an 8-bit number, so it might be something to do with individual bits. Because there's a limited, if you remember stuff from the games, there's only a limited number of PP ups you can use. I want to say it's like 3 or 4, and they only affect a certain move. So we need to, so these represent the boosts to PP. It's not this value here. This is current PP. The max PP is derived from this number. So there are, yes, bits 0 to 1 is move 1, 2 to 3 is move 2, 4 to 5 move 3, 6 to 7 move 4. Every move has 2 bits, so you can increase the move 0 to 3 times. Yeah. So for this, in fact, where is like move surf? Did I put all that stuff here? Okay, it's not there. Oh no, it's in moves.h, yeah. Fine. So we could just do max PP for everyone, for every move to begin with, although if we probably want this to be customizable, so We could set it to 0 for the moment. I'm actually less interested in these and just kind of going through all of the other like options here. In fact, you know what? No, let's do it. Let's calculate PP bonuses. I mean, maybe we can just kind of map out the functions for this section to begin with, and or whatever functions need to be done. And then in the next part we can do attacks, then we can do EVs, although actually I don't think attacks is going to need to be... there's not going to need to be much on attacks, so we can probably do attacks and EVs in one, or maybe all three. And that's, once we've done that, is the last thing we need to do to, in theory, create a Pokemon. So that's kind of exciting. Yeah. And then there's a whole bunch of to-dos here, which I can do off screen as well. So, with that in mind, what were we going to do? PP bonuses. So, this relates more so to moves. But I wonder if it's so generic it can just be in Pokemon, but then Pokemon is all about the data itself and checksums and whatever else, so I'd rather not pollute that with things that we don't really need. I mean, calculate EXP. This really could be in Pokemon as well. Dex could literally just be its own header file. In fact, I think we probably want to do that. So all of the, because these are still, this is still consisting of functions that are related to all of the data. So let's put them like towards the top of this. So we want to include CSAV Dex, and we're also going to need math. And we then need to put this in our header. So after all these enum values, we want this line. That looks pretty good. Guess we don't need to include anything else here. So over in CSAV Dex, we can just straight up delete this file. Cool. So Dex is literally just going to be the whole Pokedex, and we probably don't need anything else. Leveling rates as well. Should probably go to Pokemon.h, I think. Should we do that? Yeah. So Pokemon.h, don't know, can just go here. What is the issue? Have we not removed it from CSAV Dex? We have, so that should be fine. Might just be a little bit slow on the uptake there. Do we have errors? We do not have errors. We just have a whole bunch of warnings, which we'll need working through. Most of them are because I'm doing something funny with memcopy. What is your problem with this? Why don't you like that? Move that. Let's move that further up. What? Why does it think that I've... That's weird. Let me maybe quit Sea Lion and open it back up. Is it still gonna complain? It is not. Okay, that was a bit funny. Cool. So what was it we were gonna do? PP bonuses. So that needs to also probably be a function up here, which is going to be a UN8T. Let's do, calculate PP bonuses. This is probably going to take like some kind of input for each one. So what I mean by that is things like unsigned short, move 1 bonuses, move 2, move 3, move 4. And this can just be just multiple times we'll need to do a check, because the bonuses we set cannot be between cannot be greater than 3, so that needs checking as well, but for each one. So I don't know if we can be nice and efficient there. I'm just going to write the code and think about it later. So if move 1 bonuses is greater than 3, move 1 bonuses will just set to 3, and we'll do that for each one. So move 2, move 3, move 4, move 4, move 3, move 2. Okay, so we're clamping those down to cap out at 3, and they're unsigned, so we're pretty much limiting them to between 0 and 3. So then, this is... Let's actually go back to that PP. Why does that take me to PP up? I actually wanted to see this, because this is our sort of map of bits. So move 1 is actually really easy. So let's start by initializing this to 0. And then we will actually, we can set this straight away to move 1 bonuses indiscriminately. Then I guess we can... Yeah, we probably need to do a switch case on everything else, because based on what we get will determine how much we need to add. So case 1, 2, 3, and then a default, which is to do nothing. So if it's case 3, PP bonuses should become... It's not move 3 bonuses itself, but there's a specific value that we'll need to set here. So 2 to 3 is 4 through 8 or 7. Oh my god. I need to do something like this because I'm a fool. We can go up to... Oh, we can't actually do that in there. So from binary to decimal, let's do from decimal to binary. Yeah, okay. So that's what we want to put in. So something like that will come back in decimal as 255. So this is this is if we had all the bonuses and we were completely capped out. So let's actually do 8 zeros instead, which is going to be 0. So ignoring those, if we had a bonus of 1, then we need to add 4. So PP bonuses plus equals 4. And I think it just goes like 4, 5, or 8 even. I'm confusing myself now. This is a bit embarrassing. I have not dealt with binary numbers in so long, over a decade probably. What if I add those on? Is that just going to give me... That's going to give me 12. So that's the number we would want to add for 3 bonuses. Oh, so it is actually... Okay, yeah, it is actually 8. Yeah. And then we want to do similar thing for move 3 bonuses, which are the next numbers up. So actually it's a memorization game of binary numbers. So this one would be something like, yeah, 16, that's on there. Then it would be 10, which is 32. And then it would be 32 plus 16, which is probably 48, yeah. So 48. And then finally, why did it not copy that? It is these last 2 numbers. So this one we would want to add 64. Okay, I see. So this is going to be 64. That one's going to be 128, and then 64 plus 128 will be 192. What? Move 4 bonuses can never be 3? What if I was to... Okay, if for some reason it just always comments out the last one. Sure, okay. And that should give us a number that works. Yeah. That should be fine. So let's do that. So we don't need that. But what we do want is a uint8t, which we'll call bonuses. pkmn pp needs to be added to header file. And where did I put it? Above, below, calculate XP. So somewhere like here. So like this. Looks good. Looks good. Looks good. So calculate PP bonuses. So let's say for move 1, we want... I mean, maybe we can do 1 bonus in each one, which our binary number would be 1, 0, 1. It would look like that, and it would give us 85. So have I done that correctly? I really have not done that correctly. And that's just fabulous. Okay. What did I end up with? I actually had 249, which doesn't really look anything like that, so I think my logic was very wrong there. I would have thought that this is... that these would be... oh no. That's 12, yeah. Case 1, PP bonuses. I don't know, let's step through that function actually. Okay, so it has started out as 1, and we're going to add 4 to that. So it started out as 1, and then we added 4, and that should give us 5. It gave us 25. Why did that jump to 25? Is it my is it the plus equals notation that's wrong? Let me just see if this is... actually something we can do in a... like, surely... is it that I can't alter a value in that way inside of a switch statement? Okay, I mean, this is doing prints. It's not modifying any values. Okay, yeah, I mean, this is... this is another question for Mr. AI, I think. So let's see. It's actually doing it in the same conversation there. This code... is modifying PP bonuses in unexpected ways. Why is that the... Can I not modify values in switch cases? I'm not really sure why this would be a problem, but let's see what... Yeah, you can. Oh, because I'm not breaking after each, right? Is that why? I think that must be it. And I'm just could slap myself. Right, so let's replace end of lines with break. Yeah. Let's make them line up. That should have been one line space, but white space, but whatever. And then this one I'll just do manually. Break, break, break. I've now looked at the word break for so long, it now just doesn't look like a real word to me. I love when that happens. Cool. Okay, so if we were to try again, hopefully it will now give us the correct value, 85. I think that was what we calculated. 85, yes, lovely. What if we were to do 3 for move 4? So move 4 bonuses, 3. Or better yet, let's do 4 because it's greater than 3. So if we had 3 here on move 4, we should get 213. We do have 213. Okay. Okay, lovely. Great. So that is PP bonuses done. Next is Pokerus, and oh sorry, no, it's not Pokerus. That's on the end. The next one is Friendship, which is very simple, just between 0 and 255, I think. Does it actually say anything about that? It does not. So, yeah. That's great. That is our block sorted. Or rather, our first block. So, what we want to do is, when we start initializing some data, I guess we're going to assume that the Pokemon has already been allocated, like everything for the Pokemon. All the memory for the Pokemon has been allocated elsewhere, so we're just free to do whatever we want. So if that's the case, let's create a Pokemon data type. And let's just call it PD. And we'll just initialize it like that. And we want to say PDA or PDG. Yeah, EXP is Pokemon Dex calculate EXP based on the species. Sorry, this shouldn't be calculate. This should be Pokemon calculate EXP. So we're going to need to update this file to reflect that. But init new should be further down, yeah, so it shouldn't not be finding, it might be because we're in debug mode, it shouldn't not be finding that function. What's my problem? Pokemon calculate EXP. Lovely. We probably are going to need to pass in species. And the level is the level we want, so if level is greater than 100, level equals 100, and this cannot be const if that's the case. Cool. Yep. Calculate EXP based on species and level. There's also a held item as well. Did we do items? We did. So, this probably needs items importing. And then we need a new argument for held item. So then our PDG held item is held item. Species is species. Held item's held item. And PDG PP bonuses is calculate PP bonuses, and what was the signature of that? Move 1 bonuses, move 2, okay, move 3, move 4. Okay, this is going to be a huge function. Let's do those. Can we just like do that? And then let's do friendship, which is a another short value. So let's do that, and we will say if friendship, although actually if it's a short it can never be greater than 255 and it's unsigned, so yeah, we don't need to clamp that. We can just do PDG friendship is friendship. And actually I think it will look nicer if these are all on one line, so we can do the whole data block together. And they're still not aligned. Great. So that should be how we can initialize the growth block. We now, in probably other parts, will look at doing the other blocks of Pokemon data as well. So the plan is to initialize Pokemon data type. We will then derive the substructure order, and that is the order in which we write the data to the Pokemon. So we're making a data type in our function. We'll then use inner data, and that should be good. We can then encrypt it once it's in place. So I should probably do a comment for that as well. So once blocks are written, this is all for subsequent episodes. Once blocks are written, init the inner data, encrypt the data, and we are done. we are done creating a Pokemon from scratch. The meat of this is going to come from how do we calculate the EVs, because they are what translate into stats. So I'm hoping that's not too complex. I was never a competitive player, so I know if you play Pokemon like competitively, you know probably all about EVs. That was never me. I just knew more EVs equals more of a certain stat. I guess in the game, this obviously has nothing to do with the save data, but in the game itself, every Pokemon has base stats. And I don't know if the stat value is the base stat plus the EV. I don't really know how that works. But we'll figure it out. That's part of the fun. So probably between parts, maybe even later on today, but off of screen, I will look at the ever-growing number of to-dos and do probably some of the boring stuff like this off screen, because it's also a little bit embarrassing when I get things like this wrong, or confusing math well, they're not even really that complicated, but math equations like this I always struggle with translating into code. So yeah, I guess that's it. If you've made it this far, thanks for your patience, and I will see you in the next part. Take care. Bye bye.